Hi, welcome to the course on MySQL Basics. In this course, we're going to cover database fundamentals, database management systems, with a little bit more focus on the MySQL tech stack. So let's get started in looking at the agenda. So in the agenda, what we're going to cover what a database is and some of the fundamentals around that. We're going to cover some of the different database management systems. We're going to cover what a relational database management system, which you probably have heard of a lot because it's one of the most popular ones out there. Then we're going to cover some of the key concepts of that relational database management system. We're going to cover some of the simple techniques when it comes to normalization. And we're going to talk about implementing a relational database management system using the MySQL tech. So what is a database? I want you to imagine that there are thousands of employees and you need to find out some way of keeping their records secure, manageable, and also that you can actually edit this. So putting this in a file storage or a physical file storage like paper would not be necessarily the best way to do this because it doesn't allow you to have privacy, security, and manage the data governance for that. So you can think about a database as an isolated storage system or a container that holds those records in a secure way where we have ways to access that using things like SQL. Another example of a database would be a telephone record. So in telephones, you're going to have the address, the name. You might even have alternate phone numbers, anything that would change, and there need to be a way to keep track of this. So a database of phone records would be a good way of doing this because we could actually manage that in a stored container. Another example of a database would be a library. So a library is going to have millions and millions and millions of books. All those books may not be able to be kept in one physical location, but to keep a record of all of that data, we would log that into a database and be able to manage that and update that ongoing. That's when we kind of arrive at what a database management system is. So that's when we arrive at what a database management system is. You might be starting to think that, hey, it must be quite tedious and difficult to manage a whole host of data like that. That's when we start bringing a database management system that will allow us to connect those different files and retrieve those files in a very easy way. And there's a couple different ones that you may have heard of. And the one that we're going to focus on in this one is MySQL, which is a relational database management system. But there are different types of database management systems that have their place with certain type of data and certain type of functions. And we're going to cover that. But you just got to think that a database management system is going to allow us to literally manage all that data in a very efficient, secure, and private way. So let's talk about the history of database management systems. This goes very far back. This goes all the way back to the 1960s. So this is back when Charles Bachman designed the first database management system. But this has been an ongoing evolution of this technology. So down in the 1970s, we got introduced to one of the IMS systems by IBM. And then we moved on to a more relational model where you start seeing ER diagrams, and that became pretty widely known. Then we got into object-oriented database systems in the mid-80s. The 90s, we incorporated that a little bit more. And then in the 2000s, this is where you start to see the emergence of more of the database management system accessible to the public. And that was due to Microsoft's dominance in the market. So then we got IBM and Oracle. And in 2010s, we got online and offline databases. And as you know, now we have things that are existing in the cloud. So this is going to be a storage system or a way to manage data that's going to be around for a very long time. So let's talk about some of the commonly used database management softwares that are out there. So you know that this course is primarily focused in MySQL. However, there's a lot of them out there. We have SQLite, we have PostgreSQL, We have MariaDB, and we also have Oracle. And all of these have their pros and cons, and all of those, when you're accessing that data with SQL or SQL, will have slight differences on some of the syntax, but essentially we're still dealing with a database management system. So what are the types of database management systems? So we're going to cover 4 types that are in here. We're going to talk about hierarchical. We're going to talk about network database management systems, relational database management systems, and finally, object-oriented database management systems. So we're going to go over like why these may be favored in some situations than others. So the first one that we're going to look at is the hierarchical database management system. And you can see from the structure here that it looks like a tree. So each one of those nodes has a parent and a child data structure. This is more commonly found in file registries like Windows Registry, and it's usually connected from a one to many or one to n connection. And you can see that tree structure in node-like structure. And we're going to visit the next type of database management system that has some similarities to this, which is the network database management system. So the network database management system also has this node-like structure, and you can see how these are connected. And it's a very flexible graph-like organization. And you probably heard a little bit about graph databases in reading. This covers the flexibility of connecting a one-to-one relationship, a one-to-many, a many-to-n association. So this is an integrated data storage, and it's one of the similar or most well-known database structures for this is the RIMA database management system. Now we're going to get to the most widely used database management system, which is the relational database management system. And this is where you're going to start hearing Oracle and MySQL and some of the other ones like Postgres, because this is a very basic, simple way to store data. We're looking at storing data in 2-dimensional tables, which have a row as a observation or entity, and then the columns which divide those into dimensions or categories. And then what we do with that, we can make up relationships that connect those tables, which allow us to have a quite flexible and modeled database. So the relational database management system is used by MySQL, Oracle, Microsoft, and it's usually you're looking at 2D tables. So keep that in mind. The next one we're looking at is the object-oriented database management system. And this is usually used when we start talking about security and concurrency. So you might hear a lot about this when you're doing your reading. So an object-oriented database management system relies on kind of 2 different types of formats. One is the object-oriented and the other is the relational concepts that we just discussed in the previous slide. And this is usually used when we're talking about using concurrency and security. So you can think about object database software. Some of the concepts you might hear when you're learning more about this is polymorphism and encapsulation. So let's talk about the advantages of a database management system. So we have covered the types of database management systems, but let's start kind of digging into why we should choose this type of technology over a traditional file storage system. And one of the best things about this is the efficiency of managing that data. And the efficiency comes by that database management system stores those records or databases or data in a way that is structured, modeled, and easy to retrieve. Also, we are able to reduce redundancy by eliminating some of the processes that need to be constantly written, but in a database management system that's already set up for us. Also, that we can manage who has access to this database management system, which increases the security. and also improves the data sharing and data governance because we know who is sharing and who has access to this. It also is going to reduce processing time. And then we, of course, improve privacy by limiting who has access to that and keeping things in a stored container format. So let's talk about the pros and cons and how we can contrast this with a file system. So a database management system, we know, is a collection of data that we are not required to constantly write procedures and manage. It's already set up for us, and we can update those procedures and management at will. While if we're talking about a file system, you're going to have to write those procedures and things on demand. And when we want to contrast efficiency, we can look at a file management system, which we know that is not going to be efficient as a database management system, which gives us a variety of techniques of pulling that data and accessing that data, as opposed to a file management system, which won't have that flexibility. The next thing we're going to look at is, okay, if you might experience a crash or some kind of system interrupt, well, a database management system is going to have procedures in place that allow us to recover some of that failed data that we may have been inputting at that time, as opposed to a file system that will not have that level of recovery in place. And last, we're going to talk about security and protection. Protecting a file system is going to be much more difficult than a database management system, which we can constantly add levels of securities and layers as we need, depending on the type of data that we actually have, which also goes back to who has access to this database management system. So let's dive into what is a relational database management system and some of the properties or descriptions that we can use that are unique to this type of database management system, because it's going to be one that you have a lot of contact with as you familiarize yourself with database management systems. So you can think about a relational database management system as one, we have a collection of tables that make up a database, and there is going to be a way for us to connect those or model those. So each row of a particular table is going to be an entity, and each column is going to be a categorization or a dimension of that particular entity. Now, in these in this type of data structure, you're going to have atomic values. So that means each value can't be subdivided or changed. Also, that the columns have to be unique. So we can't have two columns with the same name. They need to be unique parts or components of that particular row or entity. Also, that the data that is connected, we will talk about how we connect those data and why there needs to be some uniqueness in how those keys or connections are actually put together. So let's contrast the difference between a traditional database management system and a relational database management system. And you can see from the table, we're going to cover quite a bit. So we know that a database management system stores files, while a relational database system stores those two-dimensional tables that we discussed. There's no support for normalization in a database management system, while we can easily construct different things for normalization within a relational database management system. So one of the most important things that we've kind of discussed is security. And we know that in a relational database management system, it's quite secure, and we can even secure down to the table level. There's minimal security in a database management system. There is, for that relational aspect of a relational database management system, we build those defined relationships. That is not something that is common to a traditional database management system. We talk about multi-user and single-user support. we're able to build a multi-user support system within a relational database system. And just to kind of contrast the different things that we talked about before, we talked about the Windows registry, which was more of a tree-based database management, and XML, and those are kind of traditional database management systems. But when we move over to relational database management systems, we're talking more about MySQL, Oracle, and SQL Server database management system. Also, you might have heard of this term here, where we talk about this section here, where there's ACID proponents. So that is an acronym. Now, let me tell you what that stands for. That's for atomic, consistency, isolation, and durability. And we talked a little bit in the previous section about things being atomic, where that value cannot be subdivided. So that is something that you're going to find in a relational database management system as opposed to a database management system. So now we're going to get into the essential parts of a relational database management system, where we start talking about keys. So a column or a set of columns can actually act as a key. So I'll give you an example. Maybe you have two columns. You have your transactions with transactions IDs, and then we have a table that has our customer that has all their transactional IDs. Well, we can build that connection between those two columns within different tables by building a relationship based on those particular columns, which we call a key. And there's two different types of keys that we're going to get into later. But you just got to remember that these are attributes or of a particular table that we can use as an essential part of connecting the relationships within a relational database management system. So let's talk about all the different type of keys. There's 6 type of keys in a relational database management system. So we're talking about primary keys, super key, candidate key, alternate key, composite key, and foreign key. Now, the two that you're going to hear the most about are the ones on those ends of that visual there, which are primary and foreign key. And we're going to go into detail on some of these in a minute. So let's talk about a primary key. And this is really, really important for us to master and understand, because it's something that you're going to use a lot when you are merging different tables and being able to select from data that we create from a join of a table. So a key is going to allow us to join different tables. So please remember that. Now, a primary key is going to have certain characteristics that make it unique. So that means it's unique values on each row. There are no null values. So that means that we cannot have a null value in a primary key column. Also, the values need to be unique, as we talked about. These can be tuples, or they can be a particular atomic value in that particular column. And they, like we mentioned, these can be single or column keys. And we're going to get into that in one moment. So looking at the table that you see below, you can see there is a student ID, and the student ID is unique because we have S001, S002, and S003. And each one of those have a name connected to it, which is Harry, Tom, and James. Now, and they also have an age attached to it. But let's imagine that that table expands to several thousand students. More than likely, if you're in America or the West, you're going to see multiple Harrys, or multiple Tom or James, because those are very common names. So that would make sense to use that column as a primary key because it does not fit the specification. It's not unique. because it can be duplicated. However, the student ID is unique to each individual student. We can also look at age. We may get 2 Harrys that are the same age, or we might get many students that are within the same class group that are the same age. This is why when you build a primary key, we need to ensure that that column has unique values and it's a unique key to a specific door or a way to join our tables. Let's talk about the nature of a super key, which is kind of going to follow the same kind of format as that primary key. So let's delve into it. This can be one column or more of uniquely identified tuples. And when we mean tuples, this is going to be 2 values that are unique. So it's a superset of a candidate key. So you can look at student ID and the GR number. So if we put those 2 together, they become unique, the student number and GR number, or the student number and the name, or the GR in the name. So these columns by themselves, with the exception of maybe the student ID and the graduation ID, would not be unique. For example, name, we know that can be duplicated. However, if we combine 2 of those values together, they make what we call a super key, and it's a unique value. So sometime when you don't have the ability to maybe get a great primary key, you can think about making a super key between 2 tables that allows you to use 2 columns or more to create a unique value that may help you identify that particular row as a primary key candidate. So looking at this table here, we can see that we can combine student ID and GR number. We can also combine the student ID and the name. So we have a lot of options here to create a super key. So let's talk about a candidate key. And the candidate key is a subset of that super key that we just discussed. So it's a set of 1 or more columns that uniquely identify rows or tables, similar to what we just called. It acts as a strong primary key. So we remember that some of the aspects of a primary key is that it's unique, no null values. So we can think about examples. We can think about this student ID. We know that it acts as a strong primary key because each one of those values are unique and cannot be duplicated. So that is what we call a candidate key. It's a subset of our super key, and it acts as a primary key, a strong primary key. So let's talk about the different types of keys in a relational database management system. We have a super key versus a candidate key. So a super key is a superset of candidate keys. So a set, you're talking about 2 or more values that create that candidate or primary superset of candidate keys. A candidate key is a subset of that superset. So it's one of the values that exist in that superset. Super keys are going to be numerically more, and then candidate keys are going to be numerically less by nature. And why is this? Because we can create more combinations of those supersets as opposed to having that unique candidate key. So let's contrast the 2 types of keys that we find in a relational database management system, which are that super key and that candidate key. So we looked at a super key, which we know is a tuple or a superset of 2 candidate keys or more. While we contrast that with a candidate key, which would be a subset of a super key. And remember, that acts as a strong primary key. Now, numerically, you're going to have more super keys. Why? Because remember, that is a combination of different type of candidate keys. So we will naturally have numerically more of those, as opposed to a candidate key, which is going to be numerically less because it acts as a subset of a super key. So the criteria for choosing a candidate key and the criteria for choosing a primary key are the difference here. So when we're choosing a candidate key, we want to make sure it's primary. Choosing a super key, we want to make sure that it follows those candidate keys and we can build a superset of those two keys. So let's get into how we are kind of selecting our primary key. And it might be selected for particular reasons depending on your modeling. So let's take a look at this table we have here. And we have a student ID, we have the name, passport number, and license number. Now, if we decide, okay, we want to ensure that we want to be able to connect different tables, and based on our primary key, that is the student ID, that becomes our primary key. And by nature, the other columns, such as passport number and license number, that are also unique, become an alternate key, because we can use those for other purposes or other merge or join. So that's, even though the primary key of that table that we chose is the student ID, we do have alternate keys that we can use for other purposes, such as passport number, which are unique, and license number, which is unique. So now we talk about composite keys. Now we talked about a superset, which is a set of keys, and now we're talking about a composite. So it's a little bit different. A composite is going to be us clubbing things together or adding them together. So you can think about two or more attributes that we put together to make a uniquely identifiable row. So think about first and last name, which can be unique, like Harry White or Tom White or Harry West. We can add those two together when there's really no primary key in that table for us to put together. And we can make a composite key out of that, which allows us to kind of make some of those identifiable non-null values that kind of follow what we would call a primary key. And first name and last name can be uniquely identified as a tuple that acts as our primary key. Now we get into the nature of a foreign key. So we have discussed primary keys in detail, and we know that a primary key follows it's unique, non-null, and it's uniquely identifiable in that table. So when we talk about foreign keys, this is a column in a table referring to the primary key in another table. So if we had that student ID, which exists in the left table, we use that key to connect as our primary relationship to another table. So in the example, in this instance, we are using the primary key that exists in the student ID table that has a name, passport number, and license number to connect to another table using a foreign table or foreign key. So our primary key attaches to the foreign key in the other table, and we are able to retrieve data from that table by joining them together, from our primary key on our main table to our foreign key on our secondary table. So that is how we connect those two relationships together, by foreign and primary keys. And we can see from the table here, we have our numbers that are student ID, and then we have a subject table. So the subject table, let's remember that we can have a student ID, which is unique in our primary table here, which is our student table. But one student can have multiple subjects. So this student ID will connect, which is unique in primary, will connect to this table, which may have multiple of the same student IDs to bring back the different subject. So maybe S001 has math, science, history with this table. So we would not have unique values as that foreign key. That foreign key could have multiple duplicates that link to different subjects. So let's dive into normalization. This is a very important topic when you are thinking about reducing redundancies, getting better queries, and just structuring data overall in a database. So let's kind of dive into the basics of normalization. We know that this is a method of organizing data, and this helps to avoid redundancy. Also, when we get into the different forms of normalcy, you'll see that it's a much better way of organizing data because it allows us to select data in a more simplified way. So what are the types of normalization? We have first normal form, second normal form, third normal form, and Boyce-Codd normal form. And we're going to dive into the attributes of each one of these so you kind of understand why these are used. So let's talk about the first normal form. As we discussed before, we talked about that word atomic, which is very important, means that we cannot separate or subdivide that particular value that exists in a table. It's a unique name for columns. So we want to have unique names for columns and no importance on the order of data. So that is kind of the attributes of the first normal form. And I'm going to show you an example of this. And what we're trying to achieve that all values kind of are in an inseparable form. And I'll show you that in 1 second in the table example next. So let's look at the first normal form. So we can see we have two tables, one at the top and one at the bottom. The first table there is just our table without the transformation using the first normal form. So what do we see? Let's discuss what we see in the first table. We see we have three names, Harry, Tom, and James. We have a unique age for each one of those, which is 21, 20, and 19. However, when we get to courses, we don't have a unique course for each one of them. We see that Harry has 2 courses that he has taken. And we know that we can subdivide those 2 courses because we can see that they're separated by a delimiter or a comma. So that doesn't follow the first normal form, which requires us to have atomic values. So the transformation that we would go down and do is ensure that we have unique columns for each of the value types. So we can know that course A is our first course and course B is our second. Then we are following the first normal form by having atomic values and unique columns, and we don't have these values that can be separated. So now we can see that Harry is taking 2 courses, which is course A and B, while our other students don't have a second course. This would be an example of the first normal form. So the second normal form. So what we want to say is that first normal form is the fundamental structure for the second normal form. Additionally, all columns must be functional in the second normal form. Then we want to make sure that no subsets of a primary key in the second normal form, so we can have uniquely identifiable records. So this form is very dependent on a primary key. So we're going to dive into an example of this so you can understand kind of how these principles help to organize this particular data. So let's take a look at this large table. We know that this large table has a student ID, first name, project ID, project name, project age. Now, this has a functional dependency, and the way we can get around that is to make sure that the primary keys in those tables are related to the dependent columns that we have. So student ID is unique in primary, and it's related to first name and age, while project ID is unique in primary and connected to project name. So we can separate those two tables to make sure they follow the second normal form, and by creating two tables, one with student ID, first name, and age, and then the second table, which is project ID, connected to the project name. So let's dive into the third normal form, which follows the second normal form. However, in this, we can have no transitive dependencies. So, for example, if we have a value that is primary, but we have a value that is dependent on the primary key and another value. And I'll show you that in an example coming up. So let's examine this table. We have student ID, first name, course, fees, and age. Now, if you look at this table, we see that student ID is unique, and we can see that the course ID is unique, which makes it primary. However, according to this table, if we make any changes to the course fee, it seems like it might be dependent on the student ID. So that is not going to work with our normalization form. What we want to do is we want to separate those two tables based off how they are structured and which columns are dependent on those primary keys. So we can separate student ID by first name and age, and we can separate our courses by course fees and the course ID, which is in the course name. So the course ID would be our primary key. Then any changes to the course fees would be reflected on that particular table, not the student ID, and will allow us to eliminate some of those functional dependencies. Lastly, we're going to talk about the Boyce-Codd normal form. So this is a strict third normal form. All columns must be fully functional, dependent on a superkey. So let's dive into this example. So let's look at this table where we have student ID, first name, course, professor, and age. So if we created a superkey which has student ID in the course, we wouldn't be able to fully describe the professor attribute. So in order to avoid that, we also want to do what we've done in our third normal form, which is separate those two by their primary key and ensure that all those columns are functional. We can do that by separating the student ID, first name, and age, which is completely dependent on the student ID. And then we can look at the professor attributes, which we know that the professor ID would allow us to have a primary key, then the professor name, then the course ID. So that would allow us to follow the Boyce-Codd normalization form. So let's look at the 5 categories of SQL commands. So as you see, we go from DDL to DML to DQL, DCL, and TCL. And I'll walk you through what those mean in each step, and I'll give you a practical exploration of these commands in MySQL Workbench. So let's just move on to DDL so we can kind of see what those particular commands are. So DDL is a data definition language. This defines the schema of the data or the database structure, and it's describing, creating, and modifying any of our existing database structures. So what are the commands that are in DDL? They are create, which actually creates a new object in the database or database. Drop, which removes the database. Alter, truncate, and this allows us to remove specific content within the actual memory or the data or the table. Comment, which allows us to add something to the data dictionary. And lastly, rename. So let us kind of go over to the MySQL workbench and kind of see how these function in action. So I'm in MySQL workbench, and if you can see on the screen here, I've opened up MySQL workbench. There is a connection for you to do the local connection, where you can click into the local connection. And then you're going to have to put in the password that you specified for your connection when you loaded it up. So I pass that in. I'm going to load in some queries for my DDL. So I'm going to go over to Query and File. And I'm going to go to Open Script. And I'm just going to open my DDL commands so you can get a better look at them. So if we wanted to create a database, you see we're using the create command, and then the database name here, and then we're ending that command with a semicolon, and that ends the actual code. So I can highlight this actual command. I can run over to this particular option, and I'll be able to execute the code. So I execute that, and you can see in our line here, and I'm going to drag this up so you can see it a little bit better. You can also change the way this is seen. For example, now it is on the bottom part of your screen. If I click this, we can change some of the way that is structured. I like it at the bottom, so I'm going to keep it there. I'm just going to pull it up a little bit more. And you can see what has happened is we created a database in MySQL. And mine already exists, so you can see what happens is I already created mine, but as we saw in the commands that we have, we can drop that database here. So let's use the next command, which is use, and I'm going to run that. And now you can see if I can use 0 rows are affected, which means we haven't changed anything. Now I can drop that database with the drop command here. So if I drop that, 1 row is affected. And if I go back up to use, you can see that the error code is going to show us that it no longer exists because we dropped it. So let's go to creating that database again with the create MySQL demo. So we're creating another database, slightly different spelling there. We can say 1 rows are affected, which means we created a database with 1 row. We can use the SQL so we can see it, and we run it. And now we can see 0 rows are affected, so we know it executed properly. We can create another table within that database. So we created our database, and now we want to create a table. So you can see create table command there, and I run that, and you can see table must have 1 visible column. So that's when we add the column here. So we expand the command to bring in the student ID as an integer, the student name as a character, and the course name as a variable character. So I can highlight that whole command, which starts with the command and ends with the semicolon, and I run that. And now you can see 0 rows are affected, and you can see we created a table, student ID, student int, varchar with the information that we wanted. Now we can alter that table. So I'm going to highlight this, alter table. And you can see what we're doing as an alteration to that table is we're adding a email. So let's add email. And you can see that that has been added. We can rename the table to student with the alter command. So alter table command, pass in the table, and then rename to as our function to say rename to students. I run that. And you can see now we have 0 rows affected because we're not adding anything to the rows, but we know it executed. We can truncate the student table here. So truncate. And we can see 0 rows affected. And now we can drop that table. So that is your commands that we can use to create a database, very easy for DDL. So let's deal with the data manipulation language, which is going to be dealing with commands that allow us to manipulate any existing data that was in that database or table. So we're looking at things like insert. It allows us to insert data into a table. Update, which allows us to modify data within a table. And delete, which allows us to remove data from a table. Next, let's look at data query language. And this is primarily what you're going to be using to retrieve data from a database. So this helps query data from the schema or database. So the select command is used there to retrieve stored data. And then we have the DCL, or the data control language. And this is usually dealing with the rights and the privileges of people who have access to that database. So we have the rights and permissions. We have grant, which provides a user the privileges to the database. And then we have revoke, withdraws the user access to the provided user. Then we have TCL. TCL is transaction control language. And this commits statements that help permanently saving data to a database. So this allows us to commit a transaction, roll back a transaction if there's any error, save, which allows us to save pointers or information in a systematic rollback, and set a transaction, which allows us to specify transaction characteristics. Filters. Now, filters are super important. And you'll see how filters work when we're in our MySQL workbench. So filters are connected to a select command, and they act as a clause to that command. So we call it a where clause. We use where. So we're selecting a column from a table where a condition is set. And then we can combine operators with our where filter. So that's going to allow us to say, select student name from the student table where course name equals accounting or history. So we can use those operators and or not to see how that data is filtered through in MySQL Workbench. And we'll take a look at some of those commands. We can also use combined filter clauses. For example, we want to select a column from a table where values are in a group or between a range. It could be a date range or a number range. We also can use pattern matching with our where clause. For example, like. Like allows us to look at a pattern. For example, I want to select a student name from the student table where the student name, like, and then maybe it's only looking at the first letter, like H for Harry. If you are not familiar with the concept of null values exist to say there's an empty cell or empty value within a table. For example, so suppose if we have student names and student IDs and student phone numbers, student name and ID is something that is going to be regularly required. However, a student may not have a phone number. So in place of that empty phone number, we have a null value, which means there's an empty cell. And this helps to avoid issues in the table by having that null value, which is like a specialized value that helps to keep a placeholder instead of throwing out missing data errors. So now we're back over into MySQL Workbench, and we're going to look at using some DML or data manipulation language to alter a table. And we also are going to look at selecting data with the data query language commands that we looked at previously. So the first thing we want to do is, access the database that we want. And if we remember, if I go back to the DML, we were using the MySQL database. But we had dropped the table. So what we're going to do is go back and re-add that table back into everything. So if I just go over to everything I want to add, we want to use the MySQL database. We want to create the student table. We want to add everything from here so we can add that back. So I'm back into MySQL Workbench, and what I'm going to do is I'm just going to rerun that table where we created the MyStudent table using the DDL commands, which were create. And I just want to create that simple table again, but make sure you're using the correct database, which is MySQL demo, and we use the use command for that. I'm going to go all the way down to create the table, and I'm going to run that again. And you can see we run that table. Now I'm going to switch over to our new script. And first, let's look at how we actually visualize or pull data from a table. And that's with that DQL language, which is the select command. So I'm going to select, and then I'm going to use a wildcard, which is the star, from the student table, just so we can take a look at what's in that table. So I'm going to highlight this select star, which is our wildcard, from the student table, and I run that. And you can see there's nothing in our table. Now we're going to use the DQL language commands, which allow us to insert data. And as you can see here, we have 3 insert commands. So I'm going to run the first one where I'm inserting values into those rows. And if you can see that parentheses, it is following the column count. So 1 is going to be our student ID. Harry is going to be the name, and the course name is going to be C001. So I'm going to run that first command. You can see that it ran, and then we can select from that table again. And now we can see that Harry is the first row of data that we have. So I'm going to run the other 2 rows by highlighting them. And then I'm going to select from that table again. So now you can see we have 3 values within that. So what we can do is we understand how we can insert. Now we can delete also. But before you delete anything, you need to make sure you're very specific about what you want to delete. So if we try to delete something that doesn't exist, so for example, we have this table with the course names C001, C002, but let's change this value here. So we have C001, C002. We can continue to use the data manipulation language to update student records. So before we jump into any other commands, let's move over a little bit to the filtering. So if we want to filter, we use a where clause. So now I'm pulling all the tables, but if I just say select everything where student name equals Harry, and I put that in parentheses because we know that's a string, and I put my semicolon to end the query, I run this, so if I want to select a clause where we say select from everything from where we want to select from the student table where student name underscore name equals Harry. So we can see that we have all our data here, but we can use a clause. For example, we can select from the student name where. So here's all our data. So we can select from that table and filter it down using a where clause. So we're selecting from the student table where the student name equals Harry. And we can see there's only one student with the name Harry, so we should only bring back one row of data. So I am going to highlight that and run it. And then you can see that we only bring that one back. So now we can see that we can also delete, but we need to specify which rows we want, what we want to delete in a similar fashion. But let's use update first so we can see how that works. Because we can also delete the whole student table, which also truncates everything. But let's not use the delete command just yet. Let's update our student table, and let me run this again where we see everything, where I select command. And if we go to update, what we want to update the student table, and we want to set the course name to 003 for who, where we add our filter, student ID 2, which is John. So if I run this, and then I select the whole table, we can now see that CC001 has been changed to CC03. So let's continue to explore using a filter. So now you can see I'm using our MySQL database. I'm selecting from the table here. So I'm going to run these two commands. And now I can see all my data again. But here is a filter with two conditions. I want to select from the student table where the student ID equals 1 or equals 2. So if we run that, we should get 2 rows of data. Now, if we change that operator to and, we will not get anything back. And let's find out why. So we don't have a particular column or row that has both conditions, student name 1 and student name 2. We have or, because we can see there's rows with or, but we don't have both. So let me show you what happens. You're not going to get anything back because both conditions are not met. Now, what we can do is say, look at our table and say, okay, we want student name 1 and we want student ID 1 and we want student name to equal Harry. So we can change that. And we can see that, yes, we have a student name a student ID 1, and we have a student named Harry. So that both conditions can be met. So if I run this, we will get a result. Now what I can do, and I'm just going to copy this line and make a new one so we can see it. I'm going to copy that and say, bring me back everything that has a student ID greater than 1 and show you what the result will be. So now we will get any student names greater than 1. Next, what we can do is we can use pattern matching. So we can also say, create another condition here. So we can say, bring me back a student name like, so like is our pattern matching. And then I'm going to say J as the first letter in the alphabet. And then I'm going to use a % sign to say anything that matches that pattern. So if I bring this back, and it looks like we have an error where student name like, because you can see this little dot, select everything from student title where student name, and all I need to do is ensure that this semicolon is there to ensure that our code will run. So I'm going to run this, and you can see we bring back everything that's like J. So we have John and J. So we can say, and student name is like, and we can further filter that down by saying the course name equals C002. And now we can have both conditions met. The pattern matches J, and we have the select here for 002. So we should only be bringing back this. And now you see we bring back a 3. And remember, you don't need to always use the wildcard. You can specify a column. So I say, just bring me back the student name instead of the wildcard. Student name. You will only bring back Jane because she meets both conditions. So you're not required just to bring back the wildcard. You can specify a particular column. Let's continue our exploration into using the where clause to filter select statements and bring back data based on conditions that we specify in that clause. So we're going to be using the student table to examine this. So you can see from the student table, we've selected the statement. We've used a wildcard, which means we're bringing back everything from the student table. And what we're doing is we're bringing back the table here. So you can see we have the student ID, student name, course name. And now what we can do is use that same select statement to filter the data based on a condition. For example, we have a where statement with the previous select statement, and we want to bring back records where the student ID equals 3 and course name is C002. So both conditions need to be met. So if I run that, we should get some data back, because if we look at student ID 3 and C002, that condition exists for that record. So let's run that. And we can see we get Jane, which has a student ID of 3 and the course 002. Let's look at the next condition. So first, let's run that table again so we can just evaluate. So the next condition says, hey, bring back student ID 3. We can see student ID 3 and course name C005. We do not have a 005 in our table. So if we run this, we get no records back because both conditions cannot be met because this doesn't exist. So it is false. So the next condition, let's look at our table again, run that select statement. And if we look at the next statement, which is we want a condition where the student ID is 1 and C001, so we're able to ensure that we can get a result. And then the next statement, it says select from student ID table where ID equals 13 and C005. So both conditions are false, which makes the select statement kind of true. But let's run our first one. Here, which is we want to be able to bring back a student table that is ID 3 and the course name 005. So since we don't have 005, we can change the statement to make it true. So if we change either one of these, so for example, let's bring back student ID 2 and C003. So if we run this statement, we will get an output, John. However, if we run this statement, both are false. And if we run that, we get no records back. The last one tells us to look for a student name. So let's run this. And we want to be able to select from the student table. And then we want to select where, but now we're using where not. The student name is Hattie. So let's go back up to our student table and run this. And we go back down. And we want to be able to bring back where not. So that means the condition is not there. So this should display all our tables. So this displays all our table records because we have where not. If we included where, it would not be a valid where statement. Let's continue to use operators. Now we've been using where, but we know there can be an additional operator with where. So we're going to use the in operator. For example, select everything from the student table where the course name is in 001 and 003. So if we run this, let's see what happens. So let's take a look at our student table. And we can use the in operator where we want to be able to bring back a student table where the course name is in this particular tuple or list. We want C001 and C003. So we should be able to bring back course names that are in these two. So I am going to highlight this and run it. And you can see we get C001 and C003 using the in operator with the where statement. So you're going to select your column from a table where the column you're interested in has these values in it. Next, we want to be able to bring back a student table where student IDs are from 1 to 5. So if we go back and look at our whole table again, we know that this will bring back everything. So if I highlight this, it's between 1 and 5. All student IDs are between 1 and 5 if I run that. So we didn't get a result because there is an error here. So we need to correct the spelling. We need student ID and now if we run this, we can see that we get back all the records because they start from 1 to 3. Now we can change this to a 2. And if we run it, let's see what we get back. We are only going to get between 1 and 2 for student records. So those are the in operators that we can use with our particular where statement. So let's talk about different aggregation functions that we use on columns to bring back an aggregation that we are looking for. For example, we may want to bring back the count or the sum or the max. These are all things we can do with aggregation functions within a select statement. So let's take a look at those. So we have a table here, which is the data of customers. And if we run that, you can see that output down below. And we have the column customer ID, first name, the middle name, the last name, city, age, mobile number, occupation, and date of birth. Now we may want to know what is the minimum age of the customer in our customer database. So we would be dealing with this particular column. And the syntax would be, we're using the select statement, we're using minimum, and then we're encapsulating that over the column. And the column would be age. And if we run that, you can see the minimum age is 18. Now, we can also change that aggregation to max, which we have here. And I'll just show you this. So I'm selecting max age from the data of customer database table, and it's 90. Now you might want to, and let me just run this again, 18. You might want to know who that customer is. And that's what we start using where clauses with our select statement. So we want to select the first name from the data of customer table where the age is 18. And now we will find out the name or the first name of that particular customer. So we highlight that and we run it, and we can see his name is here. We can also find out who was the person with the maximum age. So we can say where the maximum age is 90. So we select the first name column from the data of customer table where the age equals 90. And that is Shankar. We can also use the count aggregation function to count the number of rows in the total table. And that's why we're using this symbol, which is wildcard. So we don't need to specify a particular column. We're counting the particular rows with the count function. So we can run that. And we can see we have 10 records in that table. We can count the number of age. And we can alias that column. For example, if we count the age, and then we want to say, hey, we want to know to bring that back as total customer column from the data of customer table. And so we will get this result, the total customers, alias, and the number of customers. Now you can see that we were able to get 10 because there were 10 ages within that column. So let me just run this for you again. And we know we have 10 records and age, and we can see that there is 10 here. Let's go to the next part. where we want to select the age as total customers from Delhi. Now, we need to specify where that city is in our data set. So we see we have Delhi here, and we want to find where the city is Delhi from the table data of customers. So we're using where as our filter clause. So we're going to select the count of age. We're going to name it, use the alias. So we're using as customer from Delhi from the data of customer table where the city is Delhi. So we can look at our data here and we can see there are 4 instances of Delhi. So we should be able to count that and bring back 4. So I'm going to highlight that. And we are able to get 4 with our alias. We can use another aggregation across our numerical columns, which is average. So we're just selecting the average function, passing in the column that we're interested in using. In this case, we're using an alias. So we're renaming that column as average age from data of customer table. So let's run that. And you can see we are given 46.4 and we have some trailing decimals. And we can also use another function called round to deal with that. We can select the sum of the ages, which is another aggregation. We alias is that sum of age from the data of customer table. And now we get 464. We can get the count of first name and the city from data of customer table. Now, we may want to get the count of the first name by the city from the data of customer table. Now, at that point, we're dealing with group bys. So we're going to dive into that. So the syntax for group by is you're using select. We're using an aggregation. And then we are grouping by a particular dimension in the table. So let me just show you the whole table. Again, so I'm selecting that. So we can see we have these dimensions. And dimensions, you can think about things we can group by or way we are separating the data or the records. So we want to group by city. So we can see there are different types of cities. And then we have a numerical column that we can pass on an aggregation. So let's look at our example here. So we're going to count all of the first names, and then we're going to group them by city. So we have 1, 2, 3, 4 cities. So we want to be able to count the number of records or first names in each city. So we should be able to bring back, we know from our previous count statement, there were 4 in Delhi. They look like there are 4 in Mumbai, 1 in Calcutta, and 1 in Chennai. So if we run this, we are going to bring back the count. We are going to bring back the count of the first name, the city column from the data of customer table, and we're going to group by the city. And now you can see we have 4, 4, 1. This is a group by statement. Let's go back up and look at our data table here. And we get all of these. So you might even want to select the average age from our 1, 2, 3, 4 cities. And if we go back down, we can write a select statement. For example, select. We want the average age. We also want to be able to bring back the city. And then we want to be from the data of customer table, but we want to group by the city column. And if we run this, you can see we get the average age per city, which Chennai has the highest average, but that might be only one record there. And we have the average for the others. And you might be asking yourself, hey, can we bring back different aggregations? Yes, you can. So we can also bring back the count of the first names. First name. And that will bring back the count of the first name and the average age by city. And we run this. And now we get two aggregations within one table. We get the count and the average age. We can also alias these columns to give us an alias that makes a little bit more sense. For example, let's kind of change how we have formatted this. So we're going to just break this down a little bit. And so we can see it a little bit better with our aliases. So we're going to call this column as average age. And then we're going to call this let's call this as name records. And then we're going to get this from the city. And just make a little space here. So now if we run this, we have the average age, the name records, and city. And you don't need to always have the aggregation first. We could move that down. I'm going to copy this and actually we're going to copy the name. Let's copy the city first, because it might be better to read it this way. And we know we separate each one of these with a comma. So we have comma, 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 and then we select. And now you can see Delhi is first, average age, and the name of the records. And you can keep doing this to increase the table aggregations, which would be very informative. So now that we have a product from our group by, we may want to filter the table even further. At this point, we're not able to use our trusty where clause. We need to use a different function that we're going to be using, and that is going to be having. So as you see, we created our table with multiple aggregations, but we may want to further group things down. For example, if we just want to count, let's count the first name by city here. So we count the first name by city by using that previous select statement with our aggregation and grouping it by city. But we want to maybe only bring back the records that are more than 2. And you can see from this select statement, we selected the count of the first names. We selected the city column from the data of customer table, and we grouped by city. Now we can further filter that count, that aggregation, the count of the first name. So we need to pass in the count of first name again is greater than 2. So if we run this, you can see now we only bring back those 2 records. Now we can also select the count of name from the data of customer where the count equals 2. And I want you to think about when we talked about whether things are true, what we would get. So I'm going to run that. And you can see we bring back no records, because if we look at our total table, we can see there's nothing that equals 2. So this statement is incorrect. So we don't bring back records. But if we wanted to change that to 1, with a having count of 1, we can bring back 2 records, which is Kolkata and Chennai. We can continue to count the first name and city greater than 2, having count, and less than 2. So we can also use the greater than and less than operator to bring back information. And this is less than. We can also use the operator not, and not is symbolized with the exclamation mark and equal. So we want to bring back records that are not 4. So we should have the 2 records that are not 4. So that is a great way to group your data. It is super important, and filter that using a having clause to help us filter that table even more. So let's dive into looking at a new table, which we're going to be looking at an employee table. And in this, we're going to look at using different operators with a filter and looking at pattern matching. So let's jump in. We have the employee table here. You can see we have employee ID, first name, last name, email, phone number, the hire date, the job ID, salary, commission percentage, the manager, the department, ID. So we've selected this table, and now we want to be able to use a different layer of filter. So we've been using the where filter quite a bit, and you can see we have a select statement here, and we're bringing in the first name, last name, salary, and department ID in our main section of our select statement. And we know that's coming from the employees table. We're using where, and we want to put a condition on the salary column. And this is when we start using between and not between. So for example, I'm just going to change this a bit, change this to between 10,000 and 15,000. So we want to bring back all the first name, last name, salary, and department IDs where the salary is between 10,000 and 15,000. So I run this, and you can see it brings back our records for 10,000 to 15,000. Now we can change that operator by adding not in front of it and bringing in all the salaries not in this range. So this condition is met. Let's look at another one. We looked a little bit at the in function. So we want to bring back the first name, the last name, the department ID from employees where the department ID is in 30 or 100. And we want to order by department ID. So we know we're selecting from that employees table. We're going to look for 30 or 100 for apartment IDs. And then we're going to order by department ID. So let's just select this and run it. And what you can see, we get 30 or 100, and we get the first name and last name. And then we have order. So we can order by ascending by adding ASC, or we can order descending, DESC, at the end of our order by. So remember, that's order by the column and then the keyword that we're looking for. Now let's use those two operators together, where we're using a between or a not between and a in operator. So we're selecting the first name, last name, salary, and department from employees where the salary is not between 10,000 and 15,000. So you need to use between and then we chain another condition with and. The department ID is 30 or 100. So we run that, and there are our conditions all met. And we know they're met because we are able to return back the records that we're looking for. Now, we can start getting into other types of functions. And one of the functions that we can use is the date time function, which is year. So we can select all the employees where the year, and then what we pass into that function is the hire date. And the hire date we know is a date. And now we can set a condition saying equals and then 1987. So if I run that, then we will bring back all the records that have the year 1987. So that's quite interesting. We can also use a month here. So let's just copy this. And we can change this to month. And let me just show you what it brings back. So what we're going to do is let's do this so you can see this step by step. So let's select using the month function year. Sorry, let's use the month in the hire date. Hire underscore date from employees. And I'll show you what you get back. And then let's end that with a semicolon. And let's run that. And you can see here what you're going to get in return, 6, 7, and 8. Now, what we can do is say, okay, let's give us the count of all the records from the employees table where the month, then we pass in the hire date. And we know we have that numerical value that we put in. So let's say equals 6. And let's run that. And we can see we have 14 records. So we can also say just bring back all the tables. All the records instead of the count. And then we could run that. And if we go and check, we can see the month is all in June. So now let's get into pattern matching. So pattern matching is quite important when you are starting to do some text analysis on your data within a table, within a database. So we use pattern matching to initiate that with the word like. That's the keyword. And then we are able to pass in the percentage sign to indicate the pattern that we're looking for. For example, we want to bring back the first name from the employees table, where the first name, like, and then let's take a look at this. That means it's going to have a B in the middle. So let me give you an easier example first. So let's just copy this. And let's make some space. We're going to paste this. And let's look at the names. So we have first name. Maybe we want to bring back all the first names that have an A in it somewhere. So we can change that B to A, and then we can add a semicolon behind that to terminate the particular select command. So if I run this, we're going to select the first name from the employees table where the first name has an A within 2 characters. And that within is indicated by that percent sign. So I run this, and you can see what we brought back is everybody has an A somewhere in their name. So what if you wanted to bring back everybody that had an A beginning with their name? At that point, we wouldn't need the first one. We would just run this, and we bring back everybody with an A as the first part of their name. So in this second example, we're selecting the first name from an employees table where the first name has a B and a C within it. Then we're using the and in the column like again. So you remember that you need to ensure that you don't just chain like and like. You need to like in the column. So let's see what we get. So Bruce has a C and a B in his first name. So now we talked a little bit about using the in within those parameters, but of course we can use not in. So I want you to imagine what this is going to bring back. This is going to bring back all the records where the job ID is these two conditions and these three conditions. So if I run that, you can see we are able to get everything back. But why don't we just add another layer of complexity to this? So we had know that we've been practicing our pattern matching. So let's use and last name underscore is like, and let's say they are like, they have a B. So we initiate that with our particular quotations, and we want to say B starts their name. So we run this, and now we get back all of these conditions are met, where we have a B that starts the first name, the particular job ID, which is within this particular tuple or these two options, and the salary is not in 4,500, 10,000, or 1,500. So you can see we have set three conditions here that we can further filter down our data to provide what we need. So let's talk about the summary of what we have covered so far. We covered what is a database. We looked at many examples of a database. We looked at database management systems. We understood what is a database management system. We looked at the history of a database management system. We looked at commonly used database management software. And we looked at the advantage of using a DBS. Also, we looked at relational database management systems, and we were able to contrast that with the data management system. And we also looked into relational database systems versus a database management system. We looked at some of the keys, concepts in relational database management systems like key types. We also looked at normalizations and normalization types. And lastly, we looked at implementing the relational database management system using MySQL. We understood what SQL was and how to use that. We implemented MySQL. We looked at some of the key commands in MySQL. We looked at filters, operators, and null values. I hope you learned a lot in this course. Please don't hesitate to ask any questions, and good luck on your adventure into database systems with MySQL. Hi, welcome to MySQL tutorial. So let's dive into the agenda and see what we're going to cover in this course. So in this course, we're going to cover alias in SQL, joins in SQL, group by, having, order by, subqueries, and SQL with Python. So let's cover aliases in SQL. So what's an alias? An alias is a concept that is used in SQL that gives a temporary name to a specific table. So this can be done to make SQL queries a little bit easier to write, and also a little bit better in terms of interpreting if you have other people who have your SQL query. And we'll get into that. It's also very helpful for joins. So let's talk about joins in SQL. So what are joins? Joins is a concept where we're allowed to combine tables based on relations or keys. And this is kind of the primary concept behind relational database management software, where you're able to model the data. So we have separate tables that we can pull together based on a particular column that allows us to join those two together. To give you an example of that, we may have a column with the student ID that gives us the student ID in a specific primary key, and that table may be connected to the student name, the student information such as their social security number or their college plan, and there may be a foreign key that exists in another table, let's say a course table that has all the student IDs there and all the courses connected to that specific student ID. We combine those two with a join, and that will be joining this on the student ID column that exists in both tables. So that is the condition that we would be building it on. So what are the types of joins? So the types of joins are, we have an inner join, a left join, a right join, full join, and self join. And you'll be using these quite a lot if you are dealing with databases. And I think the two most popular ones that you're going to see are inner join and a left join. So if you can see from this diagram here, we can look at all the different types of joins. So as you know, in SQL, we use a select command to pull data from a particular table. So pulling this data from a table allows us to bring back the columns using a select command. So we may want to use two select commands to bring tables together, or we may want to join data and then select from that table. So let's look at the different joins. As you can see from the SQL joins, we are covering inner joins, left joins, we have right joins, and you can see the syntax that is added there. We are actually using the word join in our syntax. So we'll get more into that later, but I just want to be able to show you all the different types of joins you can and kind of just hit on the syntax right now, but we'll get into that a little deeper. Inner joins. So inner joins help select matching records in both tables. So you're only bringing back things that exist in both tables. So if there's a student ID in one table and there's a student ID in another table, we will only bring the student IDs that exist in both tables for an inner join. And I'll walk you through a demo of that. So let's talk about self-joining. In a self-join, you will actually join an existing table to itself. And you might be asking the question is, why would we want to do this? And the reason we want to do this is to produce a different output that is in the existing table. And let me give you an example of this. Imagine we have an employees table. We have the employee ID, we have the employee name, and then we have an ID, a supervisor ID. However, we don't have a supervisor name because the supervisor name is the employee name. So what we would do is join that table on itself so we could identify who is a supervisor and then have the employee name next to the supervisor name. And the employee could have multiple supervisors. So we want to make sure that the name is properly aligned. So let's jump into looking at an inner join. So before we kind of dive into an inner join, let's kind of make sure we have a firm grasp on the SQL select command language. So as you see here, I have a select, the star, which we call that a wildcard, which we can bring all the columns back from that table. And the name of our customer is data of customer table. So if I run this statement by highlighting and executing it, you can see we have the table there. We have the customer ID, the first name, middle name, last name, city, age, mobile number, occupation, and date of birth. So we can also look at an aggregation by counting how many records are in that particular table. And we can use count star, and that will be counting everything in the data of customer table. So I'm going to run that. And you can see we have 10 records. So we understand that the select will give us both the count by using the aggregation and the wildcard to bring back all the rows in the table. Now we have the option to select a column. So I'm just going to select the first name from data of customer. And I'm going to end that with a semicolon. If I run that, we should only get the first name back. And those are the first names. So now we're going to go one step further, and we're going to do a join. When you're doing a join, you need to specify the type of join you are using. So the first thing we're going to do is select the first table we want. So we know we selected the first name from the previous select function, but we want to bring the first name and account number back. So we can also format this where it is a little bit better. So we can use a select statement like this, and we can just put a indentation where we don't, and break that up so we can see what's going on. So we're going to use the select statement. We're going to select the first name and the account number from where? The data of customer table. Then we're going to inner join account on the data customer ID, and it's going to equal the customer ID in the account table. So the first thing we should do is take a look at the account table to understand how that table is structured. So similar to what we did here, we can just take this particular select statement and we can do from account. And this will bring back all of the particular account. So we run that account table, and then we can see we have the account number, customer ID, the bid ID, opening balance, date, a type, and a status. So we know that this particular column exists in both tables, the customer ID. So we can now fuse or merge or join those two tables on the customer ID column. So we can go back down to a join, and we can now explore what we're doing. We're selecting the first name and account number from the data of customer table. We're using the keyword here, inner join, and we're inner joining the account table on what columns? On what columns? On the data of customer table, customer ID column, the account table in customer ID column. So now remember, we had 10 records here in our data customer table. So if I run that, we have 10 records. And let's see how many we have in the account table. So we can just change this table to account. And we run this. And we have 10 also. So let's see what happens when we inner join to see what happens. So we're going to bring back both tables joined on the customer ID column. We run that. And now you can see we have the first name and the account number. And as you can see, there are first names that are repeated, but they are attached to different account numbers. Now, we can take the same select statement here and modify it similar to what we did above. So we can not bring back, the first name and account number. We can bring back the first name, and we can also bring back the count. So let's bring back select, and we're going to do count star. And we can highlight this and run it. And we also brought back 10 rows. So that is your inner join that we can use to make sure that we bring back the rows that match the left column and the rows that match the right column. So that would be our matching rows for your inner join. So let's continue our exploration into joins. Now we're going to look at one of the most useful joins that are out there, which is a left join. And this is where you're trying to ensure that your table on the left is connected to the table that you're bringing in. And the table on the left is your primary table. So we want to only bring back the records from that merge that exist in that left table. So let's take a look in MySQL Workbench and see how a left join works. So what I've done here is I've just used a select statement to look at the accounts, and I'll just run that again for you. And we can see that we have the account number, customer ID, the bid number, opening balance, AOD, A type, and A status. And these are our existing columns. So we know we can count the number of customer IDs and count the number of account numbers by using that aggregation function count. So just going to run that for you. And we can see we have 10 customer IDs. Now, account numbers, we can do the same thing by selecting count and then account number in the count parentheses in the function from account. So we run that and we have 10 account numbers. So next what we're going to do is initialize a left join. So we're going to start with that initial statement, which is select star from account. So we're selecting everything from account, and account is going to act as our left table. We're going to left join that to the customer table. Now we need to specify on which columns are we joining. We're joining on the account table dot customer ID. So the account table, the dot, and the customer ID. So the account table in the customer ID column. And we're going to equal that to our customer table and our customer ID column. So if I run that, we should get back a left join. And you can see what has happened is we have our left table here, which would be all 10 records because that's what existed in the left join in the left table. And then we brought back all the columns in the account table that match the records that exist in our left account table. So we have the account table and the customer table joined in one. So you can see on the left here is the account table, and on the right here is the customer table. Let's look at another type of join, which is a right join. So when you're thinking about the right join, we're doing a similar join. However, instead of using that left table as our primary table to ensure that the records from that table are 100% pulled, we are going to make the right table our primary table. And we want to make sure when we do our merge that the right table takes precedence and that the records that we bring back will only primarily exist in that right table and match what's coming in on the left. So let's take a look. So now we have the account table in the customer table. We are going to select from the customer table and right join on the account table. And we're going to use the on keyword to say the match on the account customer ID and the customer ID in the customer table. And so if you are wanting to see what we will get if we run this, we just highlight it and we run that. bringing back all the customer information, and that is matching in our particular customer table. So the primary table is going to be here when you do your join. If we go back up to the left join, you can see that account table was primary. So this select statement exists as your primary table when you select. Sometimes we can union a table. If you can see this table here, if you can see this query here, it looks a little bit complex, but it actually isn't. Let's see what we're doing. We're taking the results from our first select, which is left join, and our right join, and we're unioning those tables. So what do you think would be the result? So we know that we are getting the same columns back from the tables. And then one of the requirements for a union is that we have all the same columns. So you can see that from our left join, from our left join, here is the product. So I'm going to run that again. So you can see we have all of these columns. And then from our right join, we are going to have the same number of columns in the same columns. So when we union this, let's look for the result. So again, from the select in the left, you're going to see the left table represented first. So it's going to start with account number and customer ID because this is the left table, which is the account table. And from the right table here, it's going to start with the customer column. So I'm going to run that again, and you will see the customer name. But we still will have the information such as account number on the right since we're doing the right join. So if we union these two products, let's see what the structure of the table will be. So I'm going to highlight this, which is our first join. And I'm going to highlight this, which is our right join. And we are going to union those or stack those on top of each other. In order to do that, we need to have the same column. But let's see what the order of the columns is. So you are starting with the account number. And then we're moving back over to the right join. Now, we should have double the amount of rows because each one of those rows brought back information. So if we go back up to our join here, which is our left join, we can see that there are null values there. And that means those null values exist when you are having no records that match the records in the table. So now we're going to talk about the concept of grouping data. And this is super, super important because as an analyst or a data scientist, you will be grouping or aggregating data so that we can understand its group dynamic. So a group by statement helps to group rows which have similar properties or dimensions or features. So, for example, most of the time, group by function is used with an aggregation. So if we're grouping something, we also need to be able to know how to count or aggregate it. Do we count it? Do we look at the average? Do we sum it up if it's a numeric measure? Or do we look at min or max? So let's look at group bys also. So the having clause in SQL is very important because once we have done our aggregations, maybe with a group by, we can no longer filter in the traditional way with a where clause. At that point, we need to use having, and having will allow us to filter within that group aggregation. Order by. Order by is also a very important concept in SQL. So a lot of times when you have completed your SQL query, you might want to order that by a certain order. You might want to order that by ascending or descending. You might want to order that by something else, another keyword that we may use. Now, ascending usually allows us to sort the data in an ascending fashion, and then descending also requires a keyword after the order by, and then we specify which column we also want that to be ordered by. So let's look at that in practice. So traditionally, we know that we query our data using a select command, and we use a single query to pull back the data that we want, and we add clauses or aggregations to further modify that single query. Now we're going to get into going into subqueries and the importance of subqueries once you get into a little bit more complicated queries, because they are also needed. So a subquery, we will get into the details now. So here's a graphic that asks how to handle 2 or more queries at a time. Do I need to write 2 separate queries? So you might want to bring back 2 separate sets of data, which may only require you to write 2 queries, but those 2 sets of data may be affiliated and may need to be intertwined or have some connection. And at that point, we start looking at subqueries. So a subquery is a SQL command in which is nothing but a select query that contains another query. So we're selecting from that initial query that you made. So how many parts are in a subquery? You have an inner and outer part of your query. So you are going to kind of understand the difference between an inner and outer query. If you can kind of imagine the inner part is going to be the thing that runs first, and then the outer query runs second. So first, the inner query is executed. Then what happens is we get a result from that inner query. After we get that result, the output of the inner query is added to the outer query. The outer query will get executed as the final result. So just remember that. So there are different types of subqueries. You have 2 types of subqueries, and we classify them as nested or correlated subqueries. So a nested subquery executes first, and it's usually the inner select query and then returns the values, which executes the outer select query. So that was the inner and the outer. For a correlated subquery, this acts a little differently. A correlated subquery reads every row in the table and compares the values in each row against the related data. So it's a little bit more intricate. And you remember that subqueries can be used in different parts of your select statement. For example, in your clauses, such as where and in. Finally, you might be asking yourself, is there some advantage of using a join or a subquery? And often we can kind of get similar results depending on the data that we're trying to bring back. We could either use a join or we could use a subquery in some cases. So let's look at the comparison between these 2 types of actions in SQL. So we know a subquery is an inner query or a nested query. We've covered that. And it's also can be combined in a where clause, because we talked about it can be used in a where clause. A join is nothing but a query which brings back combined records from 2 tables or more. So handling complex queries. Subquery breaks the complex query into isolated parts in order to make a complex query into a series of logical steps. While a join, if we're talking about handling complex query, fetching data using a join concept traditionally is going to be faster because you're bringing back that whole table that you're looking for instead of waiting for the queries to actually fire. In terms of code maintenance, joins are not easy to read like subqueries. Sometimes it can be a little bit complicated because you got to remember with join, often we need to combine those with aliases to make sure we are following kind of the right procedures. And then when we talk about code maintenance for a subquery, it's easy to understand, and code maintenance is also at an ease. So what's the result? The result, when we're talking about the result, subqueries help to allow to use the results of another query in the outer query. And then when we have a join, all the different types of joins that we have, different types of joins. So it is often difficult to understand which one will give us the proper result. So we need to make sure we understand some of the theory we talked about at joins to make sure that we're able to return the result that we're looking for. So when we talk about optimizing, join is a good optimizer by the server, while subquery is easier to work with, but optimization is not as good. So let's dive into talking about subqueries. And subqueries are very important, and they take you to another level in your SQL understanding. And remember that we're looking at inner queries and outer queries. And as we know, usually that inner query is going to run first, and the product of that is then being affected by that outer query. So we'll dive into that. So first, we're using the data of customer table here. So we're going to just look at that table. And we see there are 10 records. We can also just eliminate the count and just look at all the records to get a better understanding of that table. We have worked with this table before, but it's always good to just familiarize yourself with the columns. So we have customer ID, first name, middle name, last name, city, age, mobile number, occupation, and the date of birth. So we can select everything from that particular table, similar to what we've done for the first part of this query. So now we are seeing that we have a where clause here, and the column that is affected is the customer ID, which is the first column here. And then it's in, and then we see we have something that we haven't seen before, which is this select statement. And I'm just going to format this a little bit better so we can see it all together. So let's go here and let's say we want to select everything from the customer table where, and now we can see that a little bit better. And let's make sure it's all aligned. So then we have another select statement, and let's just run this statement. So we are trying to understand what the condition is going to allow us to do. And the condition here is we want to select all the customer IDs from the data of customer table where the age is greater than 45. So we know this query is going to run first. And if I highlight it and run it, you can see all the customer IDs that are available there. So we will only return the records from the outer query that matches the records from the inner query here. So let's run that all together and take a look. And now you can see that we have those only records there, and we're bringing back all of the tables that match this particular condition which we created with a select statement. And that is a subquery. And we can write a subquery in the where function, the where clause, like we've done here. Let's take another look. We want to select from data a customer table where the first name, city name, and age from customer table, where the customer ID is in the select. So this is just going to bring back everything because there's no condition set on this particular one. So we know we have 10 records. So let's see what this brings us. That brings us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we can be very interesting, and we could say, okay, let's add a condition here. And we talk about pattern matching. So how about let's bring back a new one here. We're going to copy this, and we're going to alter this query before we look at any more, just so you get an idea. So what if you would select the first name, city name, age from the data customer table, where the customer ID is where, and then we want to set our column, first name is like, and then we can set our pattern matching. We can say R. And let's run that inner query to see what we get. So if we run the inner query, we need to add the date of customer. I forgot the table, date of customer, data of customer. So let's run that inner query first and see what our results are. So we can see we get 2 customer IDs. So that means when we select that we're using that in statement, it's saying that these customer IDs need to match the customer IDs from our outer query. So we should only have 2 records, but we'll be bringing back first name, city, and age now. And you can see we have first name, city, and age from that. Let's go to the next example. So we're selecting the first name, the city, and age from the data of customer table, where the customer ID is in another subquery. But let's take a look at this subquery. It is not the same table. It's an account table. So if we select all the customer IDs from the account table, if we run that inner query, that needs to run first before the outer query. Here are all the ones. So the resulting output of this will need to match that. It's similar to a join. And we talked a little bit about the difference between subqueries and joins. And we can see from this that this would be a join because we need to make sure that all of the accounts match the accounts here. That would be a left join. So I run that, and now we're able to bring back the first name, city, and age from a separate table where the accounts equal the customer IDs in the account table. Let's look at that again in another subquery. So when we write these subqueries, we can also use aggregation. So often asked, it says where the age is the max from the data of customer table. So we can see the max age is 90. And we're selecting from the same table, but we're using a subquery. So we're running that. And we get the age 90, which would be the most. So let's go back and look at the account table. We're going to write a query here where we're going to select everything from the account table. So this is everything from the account table. And we see we have all savings, but we do have a terminated account here. And we have a customer ID. So let's only bring back the customer IDs. Cust ID from the account table where the A status equals terminated. So that's our query. We run that and now we have customer IDs. We can set this as our inner query. So let's write that from scratch. So we know this is going to be our where, right? So let's say we want to select everything from the data of customer table where customer ID is in this particular subquery. So let's run that. And now we see we get those two records and all the information. Similar to what we would do at a join. And of course, we can add more layers to this. We can also add another layer to this. Where we say, okay, this is our table. What we want so this is our subqueries. So let's summarize what we've learned so far. So an alias in SQL is allowing us to provide a temporary name to a table or column. And it also makes our code a little bit more readable in the fact that we can use alias in joins, which allows us to have a little bit more readable code, and we can use those with subqueries. And we can also use an alias to provide a name for a different column or an output column that we may have created through our query. Joins enable us to combine different tables based on related columns in both tables. And we know there's different types of joins depending on the product that we want from those two tables. It provides a comprehensive look at the data that we have combined together. And we set the conditions for that combination of tables. And we know there are various types of SQL joins, and we went over many of them. The most common one is inner join, left join, right join, full join, and a self join. The group by, having, and order by clause in SQL further specify the kind of output we want to create from our query by including or filtering out the data on the basis of how we're using that clause. So we looked at the where clause, we looked at having, we looked at order by. And then lastly, we covered subqueries. Subqueries are queries within a query. The inner query output acts as the input for the outer query. So I hope you've enjoyed the course and you feel a little bit more confident about using SQL.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.